In this video, we are going to talk about solving and graphing inequalities. So first things first, we have all of our inequality symbols. So from top to bottom, we have shown greater than, next we have less than, followed by greater than or equal to, and less than or equal to. Just to point out, it's an or, not an and, because something cannot be both greater than and equal to something else. It is either equal to or it is greater than or less than. So to graph, we are going to use number lines, okay? And when I graph these symbols on a number line, of course, the number that is shown would be whatever the value is, okay? But we are going to use circles to actually identify which one is correct, okay? So for greater than, we would put an open circle. I will not actually include the filling in part because if I fill it in, then that means it also includes that number. So this tells us that we get right up against that number, but we're not actually including that number. And then because it's greater than, we're going to shade anything to the right of it, okay? Because it is the section that is bigger than what I circled, okay? For less than, it's going to be the opposite, but we're going to have an open circle still because we are not including that actual data there, right? Less than, it's not less than or equal to, it's just less than. So I'm going to shade everything to the left of that on the number line. Now when we get to greater than or equal to, now I'm going to put that circle, but I'm going to fill that circle in because we do include that number in our information, in our data. I'm also going to shade to the right again, like I did for the regular greater than symbol. And finally, we have less than or equal to. So I'm again going to fill in that circle, close circle, and shade to the left. Now I do want to point out that sometimes when we're graphing these symbols might have X on the left or on the right. So you got to be careful. We can't just use the direction the arrow is pointing because if the variable is on the side that is on the right, then it's going to look backwards compared to what we're used to. So make sure you are aware of that when you are graphing them. Our first example, we have x minus 4 is greater than negative 3. Now we're going to use the same concept that we used for solving equations, but instead of putting our line through our equal sign, I'm going to put it through my greater than symbol, wherever my inequality symbol is. And I'm going to do the same exact steps. I look here, I have one step. It's a subtraction problem, so I'm going to add 4 to both sides. Now, x is going to come down because I didn't do anything to it. I have minus 4 plus 4, that cancels out and makes it a big old 0. And of course, I still have negative 3 plus 4. Now, because these are opposite signs, I'm going to subtract them overall. Positive 4, negative 3, I end up with positive 1 because I'm taking that 3 away, okay? This inequality symbol is going to stay exactly what it was, and x is greater than 1. To graph this, I'm going to draw myself a number line. I'm going to put a 1 where I'm going to put my circle. Now this is not an equal to symbol, so I'm just going to leave an open circle. And I am going to shade everything to the right because x is greater than 1. I'm going to actually write that out. X, let's fix that there. X is greater than 1. Okay, and I'm going to shade. Let's shade that red so it looks kind of consistent here. All right. Now here is the only thing that makes inequalities and equations really significantly different. This is very similar, and we would theoretically do this if we had an equal sign too, but it wouldn't look any different. So I'm going to draw my wall through my inequality symbol. I am going to divide both sides by negative 6 because this is negative 6 times x. There's nothing between those, so I'm dividing by negative 6. And remember, I divide by negative 6, not positive 6, because I want to get this positive to go, or this to become positive. So x is truly alone. 12 divided by negative 6 gives me negative 2. Now, when we do this, if you multiply or divide by a negative, switch the inequality. Put this in that special spot. Make sure you write this in the spot that says special rule, okay? We're going to switch our inequality. What I mean by that is this is currently a less than or equal to symbol. I'm going to switch it to a greater than or equal to symbol, okay? I flip the direction when I multiply or divide only by negatives, only when it's by a negative, okay? And then to graph this, I'm going to draw my number line. I'm going to put my negative 2 on there. I'm going to fill in the circle because it's got that equal to symbol on the bottom, right? It could also be equal, so I'm going to include that. And then, of course, I am going to shade to the right. Now, how do I check an inequality? Well, it's not quite the same as checking an equal sign because, or an equation, because I can put a lot of numbers in here and have them be true, okay? So I'm going to get a collection of numbers. And this is how I know that this has to be flipped, okay? So I'm going to check a few numbers in the original. Let's say negative 3, negative 1, 0, and 2. I'm just going to plug a couple of these numbers in and see what happens, okay? So negative 6 times negative 3. So that's two negatives. Negative times a negative is a positive, so 6 times 3 is 18. Is that less than or equal to 12? No, it is not. So I know that this does not work, which is good because negative 3 is over here, and that's not what I've shaded in, okay? Negative 1 does, however, work, and I can see that because negative 6 times negative 1 gives me positive 6, and that is less than or equal to 12. And negative 1 is greater than or equal to negative 2 because it's over here, okay? So this one's good, and I can tell that this works. 0, negative 6 times 0 is less than or equal to 12. 0 is greater than or equal to negative 2 because 0 is over here, okay? So I can just pick a couple of numbers randomly and make sure that they work for both the original and my answer. That will help me check that symbol there, okay? One more example before you try a couple. Negative 1 is less than x over 4. So I'm going to start by drawing my wall, of course. And then I'm going to multiply both sides by 4 because this is a division symbol, right? If I do it to one side, I do it to the other. 4 times x over 4, cancel out those 4s, and I have x left. And I have negative 4 over here on the left. Now it is tempting to flip this, but I did not multiply or divide by a negative. My answer was negative. I multiplied my answer, but the actual number that I multiplied on both sides was positive. So this symbol should stay exactly the same. And I can check that really quick, right? I'm going to pick 0 and negative 5, and let's go with positive 5, okay? So, or actually, let's go with negative 4 and positive 4, okay? Better yet, we're sticking with 0 for sure. Let's go with negative 8 and positive 8. These are numbers that can be divided by 4 evenly, so I want to make sure I make my life a little easier, right? 0 divided by anything is 0. Is 0 bigger than negative 1? Yes, it is. Is 0 bigger than negative 4? Yes, it is. So that works in both, so we're good to go there. Notice that means I did not change this, okay? Negative 8 divided by 4. Does that work? Well, negative 2 is what I get there. That is not bigger than negative 1. And negative 8 is not bigger than negative 4, so that one does not work for either of them, so that's a good sign. And 8 divided by 4 gives me 2. 2 is bigger than negative 1, and 2 is also bigger than negative 4, so that works for both of them also. Okay, so I'm finally going to graph here real quick. I'm going to put negative 4 as my number. I am going to put an open circle because this does not have an equal sign. Okay. and x is greater than -4. In other words, -4 is less than x. So when I'm graphing this, I have to be careful. I can't just follow this arrow like I like to do personally, because I'm looking for numbers that are where -4 is smaller than all of them. Okay? So if -4 is less than x, that means I'm going to shade in things that are bigger than -4. If that is confusing to you when I write this out, right, -4 is less than x, you can change the order of this. You just got to remember that the open side goes with x. So I could say x is greater than -4. If that is a little less tricky for you, make sure that your variable is always on the left-hand side. Pause the video here, try these two problems, show Mrs. Jackson, and get it checked off. And there's one more example, so don't stop there after you are done. All right, last example. So we can do these also, obviously, with two-step inequalities. That should be a negative there. So if -3x minus 2 is greater than or equal to +7. I'm going to solve this the same way I would any equation. I'm just going to keep in mind if I multiply or divide by negative that I need to make a little switcheroo to the inequality, but otherwise it's the same process. So I drew my wall. Now I'm going to think about what two operations I have happening here. So this is -3 times x, so that's multiplication there. And then -2, so I have subtraction there. I'm going to remember SADMEG. That tells me that I do inverse operations with subtraction first. So I'm going to add to both sides. Now I'm going to add 2, not 3, because 2 is what's currently being subtracted. -3 is being multiplied, but I will deal with that when I deal with multiplication. So, -2 plus 2, that cancels out. -3x, I didn't do anything with that, so I'm going to just bring that on down. And that is multiplication, do not forget. 7 plus 2 gives me 9, and I did not do anything with a positive or negative number yet, so I'm going to keep that symbol the same it was. Now my next step is to get rid of this -3 by dividing by -3. If I do it to one side, I do it to the other. Now I'm dividing by negative, so I am going to switch this time. What was a greater than or equal to symbol now becomes a less than or equal to symbol. +9 divided by -3 gives me -3 again. -3 divided by -3 cancels out for 1, and I am left with x, or 1x, which is my final answer. I'm going to draw my number line just to be thorough here. -3 is my number. I'm going to put a closed circle because this has an equal to symbol on the bottom, so we are including that. And then, of course, I am going to shade in anything where x is less than -3. Okay, where x is less than -3. So over here, these are numbers that are smaller than or less than -3. Go give a few, you practice yourself.